Hello, everyone, and I think we'll start the session now. My name is Felix. I'm a software engineer at NVICA, and I'm here to rant about caching for 45 minutes. This is mostly directed towards developers, so there will be some code examples and some in-depth technical dives. But bear with me, there will be some visual and simple stuff as well, so hopefully we can stay awake. So, why I decided to make this presentation in the first place. As a junior developer, I often struggled with cache-related issues as working with them. And the documentation wasn't very helpful, so it was always a painful thing to try and fix. And as I moved towards my mid-level senior position, I realized that actually a lot of other developers that I worked with often face the same issues. So this started as an internal company's presentation and then moved on to the Drupal camps. The reason for why I had problems with this is even though Drupal was released nearly 4 years ago now, there are still parts of documentation that officially just contains a couple of sentences, or even worse, are marked to be expanded and have not been edited for the past 3 years. And the part of documentation that are available are not necessarily very helpful or easy to follow. For example, this is the request handling and rendering flow diagram, which might be helpful to some of us, but I really struggled with it. And then there's Twig. The screenshot has been taken today. It's a core issue thread about handling cache bubbling in specific edge case scenarios, and it has been discussed for the past 3 years, and it's still nowhere near being resolved. So why does it matter? The problem with the caching issues is if you write custom code, it's really easy to introduce them, especially if the specific approaches are not documented very well. But unlike your syntax or your code smells, you won't have any automatic tools to tell you that something is going wrong. And essentially, the only way of finding out that something is wrong is someone with a really good eye to the detail, like a QA person saying you that, hey, this block sometimes does not refresh, or maybe it refreshes too often. So that's not very helpful either. So during this presentation, we'll be talking mostly about the server-side caching and Drupal 8. We will be talking about cacheability metadata and what it is. We'll look at some practical examples, which in most cases will be just debug scenarios, and some common pitfalls. I will not be talking anything about Drupal 7, mostly because I barely touched Drupal 7 at all. Cache control HTTP headers is not going to be part of this presentation as well, because it would take another 45 minutes to just talk about them easily. Varnish, Redis, CDN implementation is also out of the scope for a similar reason, not enough time for everything, and I promise not to make that lame joke. So, let's start with the Cache API. I hope no one needs answering this question, why do we cache things, but just in case, in a simple slide, the idea is if we have very expensive computational task, or we fetch something from the database with a very massive query, or we hit even third-party services to present something back to the user, we don't want to be doing it for every single user. We want to do it once and then serve it from the cache. So, in Drupal 7, you used to just cache simply the full page from what I know from my colleagues. The problem with the Drupal 8 was that granularity was introduced, and now you can render and cache items of your page individually, and you actually do that by default out of the box. For that, Drupal 8 uses something they call cacheability metadata. Let's break this down. So metadata, according to helpful Google's explanation, is a set of data that gives information about other data. Okay? In Drupal 8, cacheability metadata essentially means it's the stuff that Drupal 8 uses to tell if it can cache your data, if it can invalidate your cache, what your cache depends upon, and how long it should be stored for. For this, cache context, tags, and max age are used. And we'll go about each one of them in more detail, so the cache context comes first. So the official documentation provides explanation like this. There is a cache context provides the declarative way to create context-dependent variations of something that needs to be cached. Very dry. I read it a few times, didn't quite get it, had to go for the examples, so here are some examples, what it does. So it's the idea that if you have a page, you need to think what sort of variations of that page exist. For example, if you have an argument in your URL query after a question mark, does the page layout change? If you access the same page through the different URL, through some DNS proxy magic, do you want to change your logo or something? Is there maybe any different language versions of that page, or even the actual main content on the page presented differently depending on what user permissions are? So this is where the cache contexts come into play. So they give the Drupal information on how Drupal should be caching your data or how it should be invalidating it. And it provides contextual information to Drupal about your cache, so cache context. In reality, they are just strings. It's a string referring to existing cache context service. When you work in your backend code with them, it's essentially just passed around as an array of strings, and you can definitely write your own cache context. The easiest examples out of the box would be languages, request format, URL, user for context. Most of them will have more specific options as well. So you can have url.path or url.query:key that will create individual cache context based on very specific key in your URL query. And they're also collapsing hierarchy to prevent duplication. But we'll touch upon this in a bit further down the line. So if you want to make one yourself for your custom module, the easiest way is probably to use Drupal console. You can use Drupal generate cache context command or Drupal GCC, and it will create a boilerplate of two files. One of them will be your main cache context class that will implement cache context interface, and then there's going to be a services definition for your module that will register your cache context. So the service definition is quite straightforward. We just have a YAML file that contains the name of your cache context, the class that it points to, and some optional arguments. The tags is an important one because it has to be there in order for the cache context to work correctly. The thing to pay attention to is the prefix of cache_context dot. It's a thing, I don't know why exactly, but every cache context service in Drupal 8 has to be prefixed with this prefix. Otherwise, it doesn't work. In fact, when you're creating your own cache context service, the only thing you can change is the postfix. And even more, if you actually use the Drupal console I showed earlier, it generates it without your custom postfix as well. From what I can tell looking on the internet, it's actually one of the common problems when people generate cache contexts and they don't work. This is because you need to have a prefix and you only change your postfix for your name. Inside your actual service, there's only 4 methods that are defined by cache context interface, the main ones, and they're pretty straightforward. So you have your constructor that is just used to inject something from your dependency injection. In this example, I'm just injecting request stack, which is passed as an argument in my service definition. Then you have your get label, which is slightly baffling. I imagine you probably have somewhere administration configuration panel where you can hover over cache context and it will tell you what it is, but otherwise I see very little use for it, but that's where you would describe it. And then the actual important bit is your cache context. So this is the string that will be used to identify your variations. This is just an example of static string, but in reality you would have, this is for one of the URL matching cache context from the core, and you can see that it actually go through the trouble of getting the root name and then attaching some hashed line to the end of it to create a lot of unique variants. And then you have your getter for cacheable metadata object. In this case, it's just an empty new instance of an object, but you could very well pass some data to it as well in your own implementation. So that's about it for the cache context creation, and to use it, it's really easy. If your entity that you're dealing with implements cacheable dependency interface, you can just use setter method and just pass array of strings, as I mentioned before. And if you have entity that uses refinable cacheable dependency trait, it's even easier. You could use just add new ones on top of the old ones with the add cache context helper. So onto the cache tags. The easiest way to imagine them, they're just kind of like labels. So if you have your page that consists of different blocks, teasers, cards, menus, cache tags are essentially a labels put in each of your content or config entities that are used to identify it in the cache. This gives you an option to invalidate only specific items in the cache when you want to, and you don't have to clear all of them. You can have multiple cache tags on a single item, or you can have multiple items with the same cache tag. So how do they work? Similar like the cache context, it's just array of string, but this time there's not even a service to use with it. It's literally just a string that you use to label something. They follow specific conventions, so you have your entity type :ID, entity type list, which is quite helpful one, and custom namespace custom key. Out of the box, Drupal examples would be nodes :3. That would be referring to the node of ID 3, term of 41, which is taxonomy term with ID 41. Node list is a pretty good one because it essentially refers to a cache tag that covers every single node that's existing in the system. And if you publish some of them, that cache tag gets invalidated. And a good example of custom namespace would be config:system performance. Also, that's how pretty much all of the config cache tags look like as well. And they can be pretty reliably retrieved from pretty much all the entities that exist in Drupal with the help of get cache tag helper. And you can easily make your own cache tags because, again, it's just a string that follows specific naming convention. Even more, there are contrib modules that help you to extend the use of your own custom tags as well. For example, there is I don't remember the actual name, there is a module for views that allows you to make your view cache be cleared upon clearing specific cache tags. So you have a nice field in your view to enter custom cache tags. We use it with quite a bit of success. In the backend, the reason they work is because every Drupal cache backend implements cache backend interface, and it declares set method that takes 4 arguments: cache ID, data, expiry timer, and array of tags. So when you're actually setting something in the cache, even if you're not doing it manually, but if it's done through the actual Drupal internal magic, you pass essentially, in this example, cache ID in green, data you want to store in blue. And for this example, I'm saying that the item should be cached in the cache backend permanently, but it still will be cleared if we will clear the cache tags of node 5 or user 7. Really helpful tool. So what does it actually mean in the backend terms? Well, we'll probably know that Drupal is very database heavy. If you don't, well, Drupal is very database heavy. So for your cache, you have quite a few tables available in Drupal database. And this one specifically is the vendor cache. And you can see that there's a full column dedicated just to tags. So whenever you're actually clearing something from the Drupal cache by its tag, essentially what happens is just a SQL query that looks for your tag, finds a row, deletes it. And that's the cache data. Again, similar situation, a table with a cache tags column. Invalidating cache tag in the backend is really easy, but in fact, most of the time, if you're doing things in the right way, you probably shouldn't even worry about it, because Drupal does a lot of cache tags and validation by default. So whenever you're editing a node, the cache tag for that node gets deleted. You update the config, it gets updated. So Drupal does a lot of the cache tag and validation by default, but if you have to invalidate it yourself, there's a cache tags and validator service and global cache object, and they both provide the same invalidate tags method. And it just accepts array of strings and invalidates them. So out of the box, Drupal uses cache tags pretty much everywhere. So this is a familiar site for the most of us. It's I think it was Drupal 8.5 fresh install. If we now enable some of the debugging tools, we can see that actually every individual block and region already has quite a bit of cacheability metadata in it, like cache tags. In fact, for a logged-in admin user in that Drupal 8 installation, this is the amount of cache tags and cache context you would have on a simple Drupal homepage without any additional magic. But if you think that this is a lot, on a paragraphs-heavy, large-scale application, your homepage might look more like this, and this is just cache tags. If it looks overwhelming, I can see why, but the whole idea of this slide is to show you that each of those individual items refers to a specific entity in Drupal, and when you edit any of them, you don't have to re-render and recache everything, just specific things will be invalidated, and that's quite a helpful thing for performance. At the core, tags and contexts are actually introduced through the Drupal 8 core interfaces. There's quite a few of them, so I listed just a bunch, and they provide the helper methods for getting and setting your cacheability metadata like context tags, max age. We won't be looking at all of them because there's actually quite a long list, but if we'll just focus on the first one, which is cacheability dependency interface, a quick look on Drupal.org API documentation shows that there's at least 72 files that declare their use of. And if we focus at least on a few of them, we can see that it's used by blocks, entities, entity fields, nodes, users, taxonomy terms, forms, etc. So it's used throughout pretty much everywhere. It's hard to find a place in Drupal where you would not have access to these things. And that leaves us the last two items on the cache API, which would be max age and bubbling. And the max page is probably the easiest one. It's just a counter in seconds how long you want to store something in your Drupal cache. The reason I'm saying it's easy because Drupal is most of the time using it as on and off switch. So it's either set to 0 and the item is deemed to be uncacheable, or it's set to -1 and it's cached permanently, and then cleared with the help of cache tags. And cache bubbling is the idea that if you have your page, as I showed previously, with different small components, when those individual components are rendered, each of them are cached with their own metadata, but also the whole fully rendered page is associated with the full set of the cache tags used for each individual component, minus the duplicates and with the collapsed context. So this means that if we look at our previous example, when we have our different regions and blocks and fields, they will all individually will be, when rendered, they will be cached using their own individual cache metadata, but the full page will have a combined set for all of them. And as you can see, the blue and the orange had the repeating cache tag of node 3, and the duplicate was simply removed for the whole page, so this would be easier for everything. Similar thing happens with the cache context. So if you have two elements with a different cache context, if one of them covers both, so if you have a parent and a child, only the parent is being used on the main page because it covers both instances, at least in most of the cases. So that was all for the cache API, and now we will go into some practical examples. The first one is starting with the custom endpoint, but the main idea about this presentation, this part of the slides, will be that this could be very well about custom controller, custom block, custom service, or custom anything, as long as you deal with entities coming from Drupal. So whenever you're writing custom API responses, you can use cacheable response interface, because as I've said, you have interfaces for pretty much anything. You can even have cacheable redirect response if you want to cache your redirects for some reason. And they allow you setting context tags and max age. And this is where the first debug example will be. So I was working on an application that had a content type of injury news. The idea was that at any given time, you only have multiple items of that content type. For each individual player that has injury, you would have each individual node. Player gets better, you remove the node, and it's all good. So let's say you have 4 injured players, you have 4 nodes, 1 player gets better, now you have 3 nodes. Simple. The problem was reported that there was a seemingly random delay from when the node would be removed from the system and when the endpoint would be refreshed. What the endpoint was doing is essentially just serving the 4 current nodes, or all the current nodes for that given time with the players that have injuries. So this is how the code for that looked like. So this is just the custom PHP backend code, and the first line in green is just us fetching all the existing published nodes. Then the block that would just return no content response if there's no one's injured, which is rarely the case, I think. And the main culprit would be this block that was just dealing with the actual response and providing the cache metadata. And it consists of just main setter that just simply sets the 4 nodes into the response. Then setting HTTP code, which is HTTP way of saying that, hey, everything's fine. And setting endpoint max age and last modified, and then getting the results. Obviously, with the caching issues, the max age and last modified are the problems we would be investigating. And spoiler alert, max age was hard-coded to 90 seconds, and 90 seconds is not really random, because the randomness was sometimes up to a few days. So the last modified is the culprit. The original way it was written was essentially that we would fetch all the nodes and then get last modified for all the nodes and set it as a value. And the example would be, so again, we have 4 nodes, And this is the code that would be working with that, getting the last modified for those 4 nodes. Very rustic, very basic code. We just loop over each individual entity in our array. We fetch the last modified timer. The timer is just a Unix timestamp, so it's a large integer, and the greatest of them is the latest modified, so nothing really complicated. We find out which one is the greatest, set it as a value, convert it to datetime object, and just return it. And that just works. But the way it was working in real life is essentially that we have 4 nodes, each within their individual last modified timer. We find which one of them has been modified the last. We associate that data with the endpoint. But when we remove it, the problem would be that next time the endpoint would be hit, the Drupal would find out that, hey, the datetime last modified value is still lower than the previous one because none of the old ones were edited. This means that even though the Drupal would try to re-render the rerunner and recache the API endpoint, the CDN would see the same old last modified value and would do nothing about it. So this is where the cache tags could come into play. So we could, instead of clearing everything on Drupal, we could use the cache tags and associate them with our endpoint. So how this would look like? We would have very similar method, very similar block of code to the one that was getting last modified timers. And we would just start by creating an empty array for our tags, looping over our 4 nodes, or however many there are, merge all of their cache tags into one single big array, and then just return unique ones without duplicates, if there is some for any reasons. And this would then be set as a set cache tags on the endpoint. That method set for setting cache tags exists because the endpoint implements the cacheable response interface. So we have those helpers. And the way it would look now is when we have 4 nodes, each of them has in their own individual cache tags, and the cache tags would be associated with the endpoint itself. So when we would decide to remove one of them, the endpoint cache would be cleared, and the modified timer for the actual endpoint would be set as well. So the whole point of this was not to teach you how to write custom endpoints, because it's not exactly relevant in every case. But a similar approach for whenever you're depending on data coming from Drupal can be used for any of the other custom codes, your custom controllers, blocks, your forms, or anything else you can think of. If you're using content entity or config entity coming from Drupal, please consider using its cacheable metadata as well. Render arrays is the next practical example. Apparently, outside of Drupal, it's really difficult to find anything referring to render array. It's a very Drupal thing. So, with render arrays, everything's pretty simple. You have your hashtag cache element on your render arrays to add your cacheable metadata. And you could do it manually, relatively easily, but we're software developers. We probably want stuff to be done for us automatically. So that's where the cacheable metadata object comes in. It helps with building the hashtag cache element, and by taking metadata from the entities you will be using in your render array and just building an array from that. So in practice, using something like cacheable metadata would be looking like this. You could create an instance of your cacheable metadata object, load whatever entities you want to use in your render array, and then build your markup using those entities. And once you're done building your markup, you can simply ask your cacheable metadata to set the context that you want from those entities, to set cacheable dependencies, the dependency from those entities, and then just apply all of that to your built render array. And it will create hashtag cache element that will do all of this for you. Hard to make any mistakes with that. And if you're thinking, hey, Drupal 8, we should be using services, you're right. There's a renderer services for that. And it uses, and it provides add cacheable dependency method that does exactly the same thing, but through the service. So the way it would look like, you would fetch your service, you would load your entities again, build your markup, and then with a slightly different definition of the helper method, you would add the cacheable dependency to a render array from an entity. And that's it. It builds the hashtag cache element for you. You don't need to worry about anything. The reason these look familiar is because the service just actually is a wrapper for the cacheable metadata object in the first place. So it just works. And the reason it just works is because inside that cacheable metadata object, there is some very basic logic, some conditional statements. And they check if the entity you're passing to it that you want to use in your render array implements cacheable dependency interface. If it does, we can use the cache metadata from it and merge it with render array. If it doesn't, it's deemed that we cannot cache this thing anyway, so the cache max age set to 0. And if the cacheable dependency interface sounds familiar, it's the one that I mentioned that is used throughout the core. So as long as its entity is coming from Drupal, or at least extends Drupal in some way, your chances are that you will have the option to use it. And then we're going to Twig. So with the Twig, it's an interesting situation. If all you're doing is using Twig in the way that Drupal documentation suggests, you're absolutely fine. You have to not worry about anything. It will be coming with the render arrays. It will be outputting them with the hashtag cache element, and everything will be fine. So if you're just doing this, that's fine. You can switch on your phone and browse something for 15 minutes now. The problem comes when you have customized Twig approach, like drilling into templates, using individual values from the render array, entity references even, and you're losing your cacheability metadata. It's not a good practice. I do not recommend doing that, and you should not be doing that. Shame on you. But reality is such that in business, you often have situations where business dictates what should be done instead of developers' pragmatism. So, for example, what if you have a project where your front end is built half a year before your back end even starts? You have to do something about it. What if your front-end team is really, really cool and they really want to use that fancy pattern library approach that they've seen somewhere in the conference? You have to deal with that. Or what if even you just inherited the project from someone who already built it that way and now you just have to deal with it? So if you're in that situation, there are fewer workarounds. Obviously, the best workaround would be, hey, just rewrite your front end to use the recommended specializations, but sometimes not all of us have half a year to do that. So for the workarounds, you can use your hooks to invalidate your caches. Let's say you update the node, clear the cache for something. You can use Symfony events for that, and you can even introduce manual cache clears. I've seen content editors having a button in admin UI to clear cache for the node after they edit it, because God knows why. My personal favorite approach would be to actually resolve the problem at the level it's introduced. So you're missing cacheable metadata in your Twig template. Let's add it back to the Twig template. So the two workarounds that work the best for this, from what I found out so far, would be these two. So the workaround A and workaround B. The A would be the idea that you would, for whatever entities you're outputting, set their field values to hidden, and then output your render array without the fields you already used. And that will not change the markup of your page, but it will also see the cacheability metadata from those fields with your template, because Drupal will know at least that they exist. Although I'm not a big fan of this specific one, because when you already use those fields, you might find that some of those fields have their own cacheable metadata that was already lost. So my preferred solution is this one. Again, it's just a workaround. But the idea here is that you create a new variable at your Twig template level, and you assign it the value of your full render array passed through the render filter. And you don't have to use that variable anywhere else in your template. What it does essentially, it passes render array through all the render functions, and without changing the markup, it still recognizes all the cacheability metadata coming from your render array and associates it with your template. So how it would work in a real life and what would you fix with it, essentially. Again, we had a project that extensively relied on paragraphs. This one actually was a combination of all the things, where we used the pattern library and atomic design. The front end was built about 4 months before the back end was built. So once both sides got done, we actually had to join them together, and refactoring at that point was too little too late. So we had a lot of templates that were drilling down to render arrays, fetching entity objects, and just selecting very specific values and then passing them to component templates. And the problem was reported that sometimes article teaser card would not update as soon as the actual node would be edited. So here's the page we're talking about. That's the card that was having problems, and that's its template code. I will trim it down a bit so it will be easier to read. So that's how it looks rendered. So from the business perspective, everyone was happy because it looked exactly the way they wanted, it did exactly what they wanted, and it was delivered on time. But the problem was in the template code. So what would happen is when you, in that specific template, is at the very beginning of it, we would fetch the entity associated, referenced in the render array. And instead of using anything from the render array, we just simply use the same entity object throughout the template. Then we would create a bunch of new variables and then just use them to pass into component library element. So the cacheable metadata for that specific card would look like this. You would have your paragraph settings config cache tag. You would have the paragraph itself that refers to the specific card. And you would have paragraph view settings. If for some reason you also have context for user permissions, even though it makes not that much sense, but here we are. And as you can see from -1, this card would be stored indefinitely until any of those cache tags or full Drupal cache clear would happen. So what was missing? Essentially the rest of the render array, which had its own set of cacheable metadata for each individual field. If we would be debugging that same render array, just a single field already shows us that we have a bunch of stuff that's not present in our main template, like node-related cache tags. So by just using the workaround B that I mentioned previously, oh, actually, that's the wrong slide. Imagine that this is the cache. Sorry, I was editing them today. We could add the missing cache tags to the template. And this essentially allows us to clear this specific template on the home page as soon as the actual node of 4.6.0.16 is being edited. Or when the node view settings are being changed, let's say we change the image style for the image, that updates the card. Or even the user, which is this case was referring to the editor who posted this thing, and if we decide to remove his articles from everywhere or change his name, the cache for this card would be updated. So this is something to consider. So that was the end of practical examples, and I'll just have a few more things to show. Like there's a very little in debugging tools. So hopefully everyone knows the services YAML for the actual your Drupal project settings, where you can enable your, in the parameters, the HTTP response debug cacheability headers. What this does in your browser or any sort of API clients you would use with every response, you would also get X-Drupal cache context and X-Drupal cache tags, which would contain a full set of cache context and cache tags that were used to create the response you're looking for. Quite a helpful tool, but it somewhat lacks the granularity because you cannot find out what was the cacheable metadata for that specific block. And then you have the renderers by someone called Wim Leers. I'm told that I'm supposed to know who that is, but I genuinely do not know. It promises some really fancy stuff like 3D flying, visual representations like the skyscrapers of your cacheability metadata in your browser. That part doesn't work. I tried it. It just has some JavaScript errors and just fails, but that's fine because it doesn't matter. What matters is that the important part works. In my opinion, the important part would be the fact that it puts inline comments for each individual component template you're using for individual teaser, block, region, where you can see exactly what cache tags are used for rendering that item, and cache context and some other settings like your cache bins. And you even, on the right side, that small block of red gibberish is essentially ability to use your browser console in a conjunction with some of module provided functions. You can provide, with the help of CSS selectors, you can select individual component on the page and fetch the cacheable metadata from them. That was a really great tool to actually conveniently, quickly use instead of having to inspect something specific. In fact, that was what I was using for showing the demo of Drupal 8 installation. That's just HTML markup of those inline comments. So to recap, we looked at the cacheability metadata, cache context, tags. We looked at how to add it to our render arrays, with templates and PHP code, and how to debug some of those things. And if you would to take away anything from this presentation, so here are probably the 4 most important points. So whenever you're writing custom code, you should be thinking of your cache tags and cache context regardless if it's a front end or back end. Just you're using any sort of entity, consider whether you're using its cacheable metadata. Use cache debug tools. So, because when you're debugging something that should not be happening and doesn't make sense, these are the really good tools to actually try and help you out to look at the cache issues. If you're using something really custom and really fancy in your front end, be it some sort of detached, decoupled front end, or just a really new and shiny pattern library approach, consider whether your Twig approach still uses cacheability metadata. It's important. And finally, I've seen developers disabling cache backend by setting it to cache backend null service. And I think it's a pretty great tool for the front-enders to use, so they would reduce the amount of cache clears they need whenever they're looking at the changes in the front end. But the problem with this approach, if all of the developers on team using it, you might have situations that some of the cache issues won't be spotted until they hit production. And debugging cache issues on production can be really expensive and really painful. So here's the list of the links used to build this presentation. I will be posting my slides on the Twitter after the presentation, and probably hopefully we'll find a way to post in Drupal Camp Spain as well. And I think we have quite a bit of time for Q&A if anyone has any questions. Great. Okay, so yeah, that was it. Thank you.